So you've been studying exponential relations. Some of the things that we've learned so far is that all of your relations are going to look something like this. Y is equal to A, B to the x, where A is the starting value and B is the ratio. Now, let's go and relate this to our Khan Academy stuff. You'll see how the ratio works, but you'll also see how it relates to Khan Academy. When we say y is equal to, we have exactly what we had before with our Khan Academy, where we have A, our starting value, but instead of B, we have 1 plus or minus the rate as a decimal, which is what you just learned a couple days ago. Now, in order to determine if something is exponential, we do a thing called, we go and check to see if the first and second differences are the same value. If they're not, then we have to check if the first ratios are the same. So in this case, we'll do the same for this. So in our population that we have here, this is our y value, this represents our x's, and this is our y's. So basically, 850, when we do our first differences, end up being these numbers: 10, 215, 220, and 225. Now what we're doing each time is we're taking the bottom number, 860, and subtracting from the top number, and we do that the same thing. And we notice that the first differences are not the same. And normally what we would do is if we found that our first differences were the same, we would say that it's linear. So in this case, it's not linear. The next thing that we're going to do is we always have to check to see if the second differences produce any same numbers. In this case, we know they're not the same. So this one is 205. This one is 5. And then this one is 15. So these are not the same, so not the same. Now because they're not the same, this is not quadratic, not parabolic, also known as quadratic. Once we've gone and taken a look at the first and the second differences, which is what we've just done here, is we go and take a look at the first ratios. Now the ratios are basically the bottom number divided by the top number. In this case, dividing those two, we get 1.024. And then 1.024 again for these two. And the same all the way down when we divide them. So technically what's happening is each time we're doing this, we are dividing the bottom number divided by the top number. So you're actually taking 8960 and then dividing by this to get this number here. Now, the fact that we have the same ratios means that this is the result. Same ratio. Therefore, exponential. So therefore, it's exponential, which is what we've been looking at. And B is equal to 1.024. So our B value, which is what we were talking about earlier in our original equation, is 1.024. Now, the basic equation always starts by starting with our starting value. In this case, our starting value is 8,750. A is equal to 8,750. So now our equation for our problem is basically this. Y is equal to, well, A, B, to the x, where y is equal to, well, 8750 times 1.024 raised to the x, where x is the number of years, and which x is the number of years since 2005. Now, if I wanted to find the population in 2020, here's what we do. Since x is since 2005, what we have to do is we have to say x is equal to 2020 minus 2005, which is 15. So we're going to use that in our basic equation. So y is equal to 8750, 1.024, all raised to the x. And all we're going to do is just substitute. 8750, 1.024 raised to the 15. And that number turns into this final answer. 12,488. Now, how does this relate to what we studied in the Khan Academy? In this case, our basic equation, if we wanted to, we could write it like this. Y is equal to 8750, 1 plus 0.024 raised to the x. So this basically is a growth equation, isn't it? So just give me a moment. I'm going to clear this up and make it a little nicer. So 8750, 1 plus 0.024 raised to the x. So y is equal to that as well. So this equation is the same as this equation. Punching it in, we get that. So now, the next thing that we have to do is we have to go and use a guess and check to find when the population is 20,000. In order to do that, we have to use our basic equation. So we always start with our basic equation. Y is equal to 18750 times 1.024 raised to the x. Now when we're guessing and checking, we have to have basic x values and y values in our chart. So the key idea is to pick a y value. So based on our original calculation, when we had x being 15, we had 12,488. The next number we're going to try is x is 20. If x is 20, we end up with, when we substitute 20 in for x here, we're going to end up with about 14,000. And in this case, the actual answer is 14,061, which is nowhere near what we're looking for. So I'm going to try, say, 27, something way higher. 27 gives us 16,600, which is a little better, but not quite as good. Next, we're going to try 34. When we try x is 34, we get 19,578. And when we try 35, we just get just enough over, 20,068. Therefore, the year is equal to 2005 plus 35, which is equal to 2040. So therefore, my final answer. So therefore, in the year 2040, we have over over 20,000, which is what we expect. Now, guessing and checking is what this thing is. So this is kind of our guess and check. So basically a guess and check is just setting up a table and going through all numbers until you get the number that you're looking for on the right side. And that's it. Your homework is available on the website.